Good morning, this is your Stat Sensei, Mr. Spensei, and this is Death Packet on regression and chi-squared. This is going to be chi-squared portions, and it'll be problems 121 to 130. So horseshoe crabs on a beach can be overturned by approaching waves. The stranded crabs may right themselves by turning over. During a period of many days on Atlantic Ocean beach, investigators categorized a random sample of crabs as either stranded or not stranded, and additionally noted their age category. The researchers wanted to investigate whether there is convincing evidence of an association between becoming stranded and age. Data from their studies are shown in the table below. So this doesn't make a whole lot of sense, but yes. Um, so which of the following is stranded and not stranded? So stranded, not stranded. So which of the following is closest to the expected value number of young stranded horseshoe crabs? So we're looking for young and stranded. Well, young is right here, and stranded is this way. Now, they're saying if they're independent. So they want us to pretend that they're independent. So in this case, we're going to have to go row total times column total over the total. All right. Our total is 805, and that's right here. Our row total is 218, and our column total is 194. So 218 times 194 divided by 805. And we end up getting 52.536. So that would be our closest answer. So our answer choice, our answer to 121 is B. Okay, the next one. The National Society of Acupuncturists asks a random sample of 450 adults their opinion about acupuncture being a reasonable form of medicine or not a reasonable form of medicine. The table below shows the responses along with the highest level of education achieved for each person selected. Okay, assuming that all conditions for inference have been met, which of the following represents the correct chi-square statistic and number of degrees of freedom to test whether there's an association between level of education and opinion? So they say association. So that lets me know that this is a chi-square test of independence. The other way to look at it is I have a random sample, two variables, one sample, two variables, chi-square test of independence. Now, these are my observed values. Remember, the formula for chi-squared is chi-squared equals observed minus expected over the expected. So observed minus expected squared. So we need to have the observed is all the first number, and the observed will not be in the denominator. We need to have the expected. So it looks like to me, just looking at it real quickly, I've only glanced at it, that it looks like the observed is exactly in the numerator. It may be in the denominator, but I haven't checked that out. I'm going to go ahead and talk about the degrees of freedom. So the degrees of freedom for a chi-square test of independence and homogeneity, degrees of freedom is rows minus one times columns minus one. Well, our rows, we have one, two rows. Don't count the total. So we have two rows, two minus one, and we have one, two, three. Don't count the total, three columns. So two minus one times three minus one. Two minus one is one, three minus one is two. So our degrees of freedom is two. Well, right there, that gets rid of three of them. So we're down to B and D. So I need to check to see whether or not to find out which one is the correct one. All right. To do that, I need to calculate the expected values. Now, it turns out there's an error that they made, so I can find it without doing it, but I still want to show you how to calculate the expected values. The expected values, if I go blue matrix, matrix is that button, over to edit, and I have 2 rows, 3 columns. It's a 2 by 3. So 2 enter, 3 enter, and 100 enter, 80 enter, 60 enter. Please don't input the totals. Don't input the totals. 70 enter, and 80. Blue mode, then stat test chi-squared test. Make sure it's the chi-squared, not the GOF. GOF is goodness of fit. We want just chi-squared. And there, we have our value. Now, if I go back to the matrix, so blue, back to matrix, arrow over to edit, and drop down to letter B. And now I see my um, my expected values, which are 85.33. That checks. 80, check. 74, check. 74, check. 70, check. 65.3. Okay, so the top row is right. But look, I don't have that. These are wrong because those need to be expected values. So let's make sure that we have it right here. Observed minus expected, expected, yes. Observed minus expected, expected, yes. So this is the one. So our answer choice to 122 is letter D. Moving on to 123. Data was collected from a simple random sample of 200 cell phone users, age 18 or older in the United States. Each user was categorized by age group and whether he or she used a certain cell phone app. The table summarizes the data with expected cell counts in parentheses. Which statement is true about the conditions for chi-squared test for independence have been met? All right, so what are our conditions? Well, we need a random sample. We have one. All right. We need to have all of our expected values have to be greater than 5. Uh-oh. We have an expected value of 3.42. All right. So all necessary conditions are satisfied to apply chi-squared. Nope. The data from the different age groups are not the result of independent random samples. No, they said they were. It's not samples, it's sample. And they wanted a test of independence. And remember, test of independence is one sample, two variables. Well, we have one sample, two variables. To have, if you multiple samples, that's a test of homogeneity. The total sample size in one or more age groups is too small. We don't care about the total. We don't care about the total sample size. We care about the expected value. You could observe 0, and that's fine, as long as the expected value is greater than 5. Not all the observed counts are large enough. Not a problem. Not all the expected cell counts are large enough. That's our problem. We have a 3.42. That's not big enough. So the answer choice to 123 is E. 124. Manufacturing company with 350 employees is changing the employee health insurance plan to either A or B. The company wants to know if employees have a preference between the two plans and whether or not preference difference between those employees who have family members covered under the current plan, group 1, and those who don't in group 2. The Human Resources Office take a simple random sample from each of the two groups. Oh, a simple random sample from each. That means I have two samples. As soon as I have two samples, this makes it a chi-square test of homogeneity. All right, so we have a chi-square test of homogeneity because we have a random sample from group 1 and a random sample from group 2. So in this case, It says, which statement is true about whether the conditions for chi-square test of homogeneity have been met? Um, First off, the first question, which statement is true about whether the conditions have been met? A simple random sample should have been taken from all of the employees, and then each employee in the sample would have been asked. No, it's not from all employees because we're taking two samples because homogeneity requires two samples. The expected cell counts are not large enough. Well, I'm looking at the expected 32, 13. We needed to be greater than 5. All of these expected are greater than 5, not a problem. The total sample size is not large enough to apply the chi-squared test of homogeneity. That's not an issue. We need to worry about the total sample size being too big. So hopefully they have 350 here. So hopefully they have a population size that's large enough, but we don't know that yet. All right. So when I look at this, we get to the last one. The total sample size is too large. What's my total sample size? 85. So if I go 85 times 10, that equals 850. That's greater than the 350, and we have to be less than 350. We have to be less than the population size. 10 times our sample has to be less than our population. So if our population is 350, we could not have had our sample should have been 35 or less. So in this case, the total sample size is too large. Our answer choice is D. 25. Juvenile ground squirrels respond to predators by making alarm calls that can alert others to danger. A biologist conducted a study to investigate how squirrels respond to these alarm calls: run to burrow or freeze. All right. The biologist played recordings of alarm calls for 3 samples of ground squirrels grouped by age and observed the squirrel's response. The data for the 3 age levels are shown in the table below. Hey, I have more than one sample. They said we have 3 samples. As soon as they tell me it's 3 samples, this is a chi-square test of homogeneity, just as a reminder. If ground squirrels at different ages respond to alarm signals in the same proportions, that tells me chi-square homogeneity. What would be the expected count for 6 to 15-day-old squirrels that freeze? Awesome. So 6 to 15 and that freeze. Once again, define the expected count. Row total times column total divided by the total total. Row total times column total divided by the total total. Total total is 98. So we're dividing by 98. Our row total was 40. Our column total is 49. So 40 times 49 divided by 98. The answer choice to 125 is C. 126. The district manager of 4 different restaurants wanted to investigate whether the 4 restaurants differed with respect to customers ordering dessert or not based on family classification, with children or without children. All right, so we have 4 different restaurants. Independent random samples. All right, multiple random samples, homogeneity. Who ordered dessert were selected from each restaurant, and the customers were identified as either being children or without children. After verifying the conditions for the appropriate hypothesis test, the manager calculated a chi-squared test statistic of 6.45 with a p-value of 0.095. All right, and the alpha is 0.05. What conclusion should the manager make regarding the proportion of customers who order dessert at the restaurant? All right, so let's talk about what our null is. Our null hypothesis in this case for homogeneity are the proportions, essentially the proportions are the same. Proportions are the same. regardless of restaurant. The ha is the proportions differ, or at least one differs. All right, so the proportions differ. Okay, they're not the same. Well, in this case, our p-value they said was 0.092. Our alpha is 0.05. This is greater, so we're going to fail to reject. If we fail to reject, that means we don't have enough information. All right? That means there's not enough. So this says there is convincing. Nope. There is convincing. Nope. There is not. Oh, I got to read that one. There is not. There is not. So I got to read C. There is not convincing statistical evidence to prove we don't prove anything. There's not convincing statistical evidence to suggest the proportion of customers who order dessert at the restaurant is the same. We don't, that's not it. We have to restate the alternative. Our alternative is differ or not the same. So hopefully E is going to be better. There is not convincing statistical evidence to suggest the proportion of customers who order dessert is not the same. I wrote different, but remember the null is are the same. The ha is different or not the same. So our best answer choice is E. Because basically we'd say our p-value is 0.092, which is greater than our alpha or 0.05. We failed to reject the null. There is not convincing statistical evidence to suggest the proportion of customers who order dessert at each restaurant is, restate the ha, not based on family classification. All right, number 127. As a first step in developing a new drug to treat cancer in humans, an initial study of the drug is undertaken in rats. 300 rats with cancer are studied, and each is assigned to one of three treatments. Okay, this is really important here. Assigned. As soon as assigned, we don't have to worry about the N is less than 10% condition. To one of three treatments. 100 rats are randomly assigned to a high dose, 100 are randomly assigned to a low dose, and 100 are randomly assigned to a control group. After 6 months, each rat is examined and classified as having developed no tumors, one tumor, or two or more tumors. Which of the following would be an appropriate alternative hypothesis in this study? So the null would be there is no difference in the tumor status across the three treatments. All right. So in this case, we have multiple um, samples. We have the sample one receiving low dose, sample two receiving high dose, etc. So we had the three dosage. That's our samples. All right, and so this is a chi-square test of homogeneity, and so there's no difference in the distribution of tumor status. That would be our HO. The proportions are the same. There is a difference in the distribution. That's looking pretty good. That's our ha, and they asked us for the alternative. So that's looking pretty good. I like this one. There's no association, not a test of independence. There is an association, not a test of independence. All right. The proportion of rats with no tumors is the same for each treatment group. That would be another way of saying the HO. All right. At least in my opinion, that is. So in that case, 127, the best answer choice is B. All right. Because we're looking for the ha. Ha for a homogeneity. 128. Ecologists conducted a study to investigate the potential ecological impact of golf courses. Investigators monitored the reproductive success of bluebirds in birdhouses at 9 golf courses and 10 similar birdhouses at non-golf courses. All right. Data on nests and bird occupied only by bluebirds are shown in the table. So we have two groups, golf courses and non-golf courses. So essentially we have two samples, all right? If the proportions, and by the way, that's why they're talking about proportions, because we have two samples, one of golf courses, one of non-golf courses. This makes it a chi-square test of homogeneity. If the proportion of nests occupied is the same for golf and non-golf, what would be the expected count with one nest in non-golf? So one nest, non-golf, and they're asking me for the expected. Once again, it's going to be row total times column total over the total. Well, our total is 200. Our row total is 120. And our column total is 100. Oops. So 120 times 100 divided by 200. And we get 60. So our best answer choice for 128 is E. All right, 129. As a first step in developing a new drug to treat cancer in humans, an initial study of the drug is undertaken in rats. 300 rats with cancer are studied, and each is assigned to one of three treatments. Okay, as soon as we assign them, we're not worried about N is less than 10%. All right, we're not worried about in condition two. 100 rats are randomly assigned to a high dose of the new drug, 100 random to a low dose, etc. After 6 months, each rat is examined and classified as having developed no tumors, one tumor, or two or more. Which of the following would be an appropriate alternative? All right. In the study, and it's a chi-square test of homogeneity. Why? We randomly assign to three treatment groups. So essentially, we have three samples, one with low dose, high dose, and no dose. So they're asking for the HO. They're asking for the HA. All right. Well, in a test of homogeneity, proportions need to be the same. The HA would be the proportions are different or not the same. So there's no different in the distribution of tumor status across the three treatments. No, that's like a HO. No difference. All the proportions are the same. There is an association. No, we're not looking for an association. That's test of independence. There is no association. That's also a test of independence. There is a difference in the distribution of tumor status across. That's telling me the proportions are different. We're looking for AHA. The answer for 129 is D. All right. All right, on to question 130. A state highway commission is considered removing the lane that allows people to pay cash for a toll on a toll road and requiring all people who use a toll road to pay with an electronic transponder that is connected to their car. The commission wants to know whether the proportion of people who live in northern part of the state and are in favor of removing the cash lane is different from the proportion who are in the southern part of the state who are in favor of removing the cash lane. Independent random samples. Whoops. As soon as we have independent random samples, this is a homo. This is homogeneity. All right? Homogeneity. Are selected from the northern and southern parts of the state. The table summarizes the responses. Which of the following is closest to the p-value of the appropriate test to investigate whether the proportion, etc.? Well, as soon as they're telling me they're looking for the p-value, and I know that I'm going to have to run a chi-squared test, we ignore the totals, and we're going to focus on the part that are not the totals. So we're going to go second matrix over to edit, and I have 2 rows and 2 columns, so this is a 2 by 2, and I have 112, 98, 89, 105. All right. So, and by the way, once again, that was the blue button, and down here at x-1, there's this matrix above it. That's what I was looking for. So we'll press enter. Then we're going to go blue mode. And now we're going to run the test. Stat test. Make sure you choose chi-squared. GOF is goodness of fit. We just want chi-squared, which will run test of independence and homogeneity, and this is homogeneity. We're going to press enter, and we get a p-value of about 0.1342. So our answer choice for 130 happens to be B. All right. I appreciate you watching and look forward to seeing you on the next one. Thank you.